Hello, everyone, and welcome to How It Works, the channel that makes complexity simple. We take everyday questions and turn them into clear, visual explanations. Curious minds are always welcome, so don't forget to subscribe, and explore with us. How touchscreens work. A deep dive into modern interaction technology introduction in the digital age. Touchscreens have become an essential part of everyday life. From smartphones and tablets to ATMs, cars, and industrial machines, most modern devices rely on touch interfaces to allow direct interaction between humans and machines. But have you ever wondered how a touchscreen actually works? In this essay, we'll explore the different types of touchscreen technologies, the science behind them, their advantages and limitations, and where they're used. What is a touchscreen? A touchscreen is a visual interactive display that responds to touch input from a finger or stylus. Instead of using a keyboard or mouse, users can interact directly with what's displayed on the screen. This creates a more natural, intuitive, and faster experience. How does a touchscreen work? Most modern touchscreens operate by detecting electrical changes that occur when a conductive object, like a human finger, makes contact with the screen. A typical touchscreen is made up of a glass surface, a thin, transparent conductive layer, often made of indium tin oxide sensors that detect changes in voltage or capacitance when you touch the screen. A small amount of electrical charge is drawn to your finger. Sensors around the edge of the screen detect where this charge was lost and calculate the exact coordinates of the touch. The device's software then interprets this action and performs the appropriate response. Types of touchscreen technology. There are several different types of touchscreen technologies, each with its own working principles. 1. Capacitive touchscreens. These are the most common in smartphones and modern devices. They detect touch using the body's electrical properties. They measure changes in the electrostatic field when a finger touches the screen, known for high sensitivity and multi-touch support. Pros: high sensitivity and responsiveness, multi-touch support, high clarity and brightness, no moving parts. More durable. Cons: don't work with gloves or plastic styluses, more expensive than resistive screens, sensitive to electromagnetic interference too. Resistive touchscreens still used in ATMs, point-of-sale systems, and industrial equipment. Consist of two flexible layers that touch each other when pressure is applied. The device detects where the layers make contact and calculates the touch point. Pros: can be used with any object, cheaper than capacitive screens, reliable in dusty or wet environments. Cons: lower sensitivity and clarity, usually single touch, only less durable due to mechanical contact. 3. Infrared touchscreens use a grid of invisible infrared light across the screen. When an object interrupts the beams, the system detects the touch location. Pros: very clear display, works with any object. Durable. Cons: affected by direct sunlight, usually more expensive, requires larger bezels to house the sensors. 4. Surface acoustic wave touchscreens. These use ultrasonic waves across the screen surface. When touched, the waves are absorbed at that point. The system measures the interruption to determine the touch location. Pros: excellent clarity, works with fingers, gloves, or soft styluses. Long-lasting. Cons: sensitive to dirt or moisture, not ideal for outdoor use, more expensive than other types. Why don't touchscreens work with gloves? Capacitive touchscreens detect electrical conductivity, which standard gloves block because they're made of insulating materials. This is why regular gloves don't work. There's no electrical connection. Special touchscreen gloves have conductive material at the fingertips to allow interaction. Advantages of touchscreen technology: direct interaction with content, intuitive use, easy to learn for all ages, compact design, no need for external input devices, flexible interfaces, can adapt to various layouts, supports gestures like swipe, zoom, tap, accessibility friendly, useful for users with disabilities. Limitations of touchscreens: less precise for long typing or detailed drawing, prone to fingerprints and smudges, can cause arm fatigue over time. Some don't work with gloves, maybe more expensive depending on the type, risk of accidental touches. On large screens, applications of touchscreen technology. Touchscreens are used in a wide range of areas: mobile devices, automotive systems, ATMs and ticket machines, retail checkout systems, medical equipment, education, industrial control panels, public information kiosks, gaming, smart home systems. The future of touchscreens and technology is rapidly evolving. Innovations include advanced haptic feedback to simulate physical buttons, 3D touch and pressure sensitivity integration with augmented reality flexible and foldable screens, touchless gesture control, improved energy efficiency for longer battery life, increased accuracy and durability. Conclusion: touchscreen technology has completely changed the way we interact with devices, making them more intuitive, efficient, and accessible. By understanding how touchscreens work, we gain a better appreciation for the science and engineering that power our everyday digital experiences. As new advancements continue to emerge, touchscreens will become even more powerful, flexible, and central to how we live, work, and play in the digital world. Thanks for watching How It Works, where we make sense of the world, one topic at a time. If you enjoyed this video, don't forget to like, subscribe, and share it with other curious minds. See you in the next one.